Right, okay, so let's hand over to Maurice.
Okay, so well, I've brought a few demonstrations of what I've done at Reedham Junction. So basically we moved Reedham Junction signal box from Reedham Junction, which is on the line between Norwich and Lowestoft and Norwich and Yarmouth. We moved it to Holt, and I was asked would I have a go at building a simulator after the previous person that was going to do it dropped out, and also openSignalbox wasn't completely ready at that stage. So what I've done is I've built a simulator for Reedham Junction. It's specific to Reedham Junction, but in the long term we will probably move it over to openSignalbox in time. So I've wired a whole load of different devices that I've made using ESP devices that you can buy from China off the shelf, including this you know, from AliExpress basically. And this, which is a 7-inch thing made by Waveshare, which they only about £35. But this is actually the simulator. So the whole code for the simulator is on this little device, which basically runs in one of these little ESP processors. So there's one of those processors in here, and in every device in my simulator. So this is part of the tokenless block, which I'll talk about in a minute. So basically, just to give a quick demo of how Reedham would work, if you've got block instruments, which I haven't bought block instruments with me because obviously there's quite a lot of stuff. The only block instrument I bought is the tokenless block. But basically, if I want to send a train, I can say offer a train from Yarmouth. So that should now offer me a train. So with tokenless block, obviously there's no token. There's two instruments which look similar to this, except there's actually an indicator like the sort of normal indicators with a galvanometer in it. And basically what happens is the signal at the other end now is saying I want to send you a train. So what I would cancel the buzzer, I would say I'll accept the train, and because he's pressed his offer button, so now the train is accepted to go into the single line, which means he can now pull his starters. Okay, so basically in a few moments the train will enter section. So when the train passes the first track circuit after the starter, it will automatically go into train entering section, and it will warn me again with a buzzer. So that will take, I think I've set it for about 30 seconds.
Exciting.
You can edit these bits out. It's a long time when you're waiting for it. But when you're doing demos to punters at Reedham, it's quite nice to have the extra time. So people ask questions and so basically between my devices I'm using a protocol called ESP now, which is a Wi-Fi protocol. So the train is now online, so I'll just accept cancel the buzzer. So basically now we're showing the train is in section, it's past the starter. If before it passed the starter I'd set that switch back to normal, it would put the starter signal at Yarmouth back to danger. So the signalman at this end both of those starter signals are motor operated. So if you go back to normal with the train accepted, it will put the starter back to danger despite whatever the signal at the other end is doing. So there is a way of stopping the train, but now the train has passed the starter, it can't be stopped. In modern days, of course, I suppose they use radios, don't they? They can talk to the train drivers, but in the case when this was done in the 60s, they wouldn't have been able to. So basically a length of time will happen. I have just made this light flash to indicate there's a train online, but it's not actually necessary. But that's just in my device, which will be hidden in the relay room in Reedham. But it's useful for me when I'm debugging as to what actually the device thinks it's doing. So at some point the train will arrive. So it will send a message to my simulator panel. So what I've done here is I've on this this 7-inch display, which would you normally buy these, that they're used for sort of house controls, you know, thermostats, things like that. You'd have your weather on it or something. And I've taken Owen Stratford's Reedham Junction diagram, reduced it to the correct resolution for this display, and I've also put various control buttons and the state of all the signals and levers that matter to operate the simulator. So there's 60 levers at Reedham, there's 32 there that that I'm actually displaying. There's 32 that I need to detect the position of. So the train has now arrived at our track circuit D. I know it's very, very tiny there. So it's waiting at signal number 55. So I can clear the signals. I've got this device here. Because I've not got the levers, we're not at Reedham, I can actually clear the signals with this. So here I've got a display that actually shows the 32 lever positions. Okay, so basically this is my lever detectors, which I'll talk about in a minute, send a message. This is just detecting that message so that I can see what the state signals are, but also you can see here signal 55 is now off and the train is proceeding. To give him a route through, he'll need 54 off, 53 and 52, which I would have to at Reedham offer him via the instrument, because 52 is the starter. So we've now got those signals off, and the train will now progress through the diagram, across the crossings and on to Cantley, basically. So this is working as the wheel simulator. So if I was at Reedham, this is talking wireless messages to illuminate the diagram, and there's devices which will receive these wireless messages and operate the relays for the diagram. And also the train has now passed C. So on receiving a train on tokenless block, you're looking at the first signal beyond the home signal, okay? The first track circuit beyond the home signal. That has to have occupied and cleared, and then I can say, put the instrument back to normal and say train arrive when I've checked the tail lamp, and the instrument will now go back to normal. So now either I can send a train or the other end can send a train. Okay, if I wanted to offer a train, I can just say offer, and if his instrument is in accept, then the train will be accepted, so I could send a train, and that will now have released my starter going in that direction. Probably in the real world there'll be more interlocking. I wouldn't be able to do that with these signals off, but it's just a demo. So basically the train has now progressed across the crossing and it's now working into the station, and it will, if you want to have a close-up, so that would be lighting the real diagram in reality, but obviously I've not got that here. Just as a demo, you might just see it operate a couple of times. It might be nice to edit in. At the moment, my track circuit times are all constant at about 15 to 30 seconds.
Actually, so that I was just going to ask a question about the timing and how that happens.
It's all in a structure in my code, and it's all just set at the moment to probably about 15 or 30 seconds, depending on the track circuit. My plan eventually is that that will come from a database, so you'll be able to say this is a train of type slow passenger, and it will have these times going through the route in this direction. That's a feature still to add. At the moment everything just goes through at standard speed, and also length of train would matter because some of these track circuits are short, so you would expect 2 or 3 of them to operate at once. But that's a future feature for me to do when I've got a bit more time to program it. So the only other thing I was going to talk about and demonstrate was my lever detector. So my first plan at Reedham, I've got 32 levers I need to detect. My first plan was to get some little magnetic sensors, which are basically like metal detectors. So they detect the levers near them. And that my idea was then you've got on and off, or normal and reverse. But then I thought, well, this particular type of little M5 atom processor has an inertial unit inside it, and that basically allows me to measure the direction of gravity in all 3 planes. Like if you've got your mobile phone, you've seen the games where well, that has one of those devices in. So what I thought was maybe I could attach that to the lever and use that to detect the lever position. So I built this mock-up with my 3D printer, which has the exact same movement of the lever as the lever at Reedham Junction. Okay, and what this does is this has about 2,000 different points that this can measure in terms of the movement of gravity in the Y direction. And so what I've done is I've written the code such that I've got two indications. I've got on and off, which is relevant for the simulator, but also in terms of locking, sometimes you want to know normal, A, B, C, D, E, reverse. And so as the lever moves, it sends messages. This white light is a message, and you can see the A, B, C, D, E position shown. And then when we're off, the signal is off. So that's what I'm doing with this little inertial motion unit. It will self-calibrate, so if for some reason it gets out of adjustment, it will readjust itself. I have had interesting fun and games programming this, because when you attach something that's really meant to be in a mobile phone to a 100 weight of metalwork, the metalwork rings. So as you clatter the lever, everything's shaking. And of course, this thing can detect in the microsecond frame time frame, you know, 2,000 movements from there to there. So I've got very big swings. So it would suddenly go 5,000, 8,000, 200, like that. So what I've had to do is I've had to both turn on the smoothing in the device itself. So the device in its registers has smoothing that you can turn on, and I've also, what I do is I create an array of 32 points and average that over each measurement period, which is probably about a couple of milliseconds, so that it doesn't actually ring if you throw it back. You see now, you can throw it back and it will actually do the measurements and not do something silly. I haven't used the ABCDE feature yet, because at Reedham, all of my I'll show you one of my diagrams here. At Reedham, all of my train. That's the hazard rim and signal box, is that you get trains. Yeah. So at Reedham, I inherited all the relays. So I'm actually implementing all the lever positions actually with circuit controllers within the lever locks. So I'm keeping the operation of all the levers in my circuitry at the moment. But obviously this could be used where you haven't got the relays and you want to do all the locking electronically in your simulator. That will give you the option. But at Reedham, I've put all the wiring back. Had the upstairs relay cabinet was still wired, but we removed some of the wires because it went to a very modern connection box which wasn't in keeping with the box. So I've ripped all of that out and put a whole new load of wiring in. Downstairs was unwired and I've rewired that from scratch. So, but luckily I work at the Mid Norfolk Railway and I've had a good teacher in Richard Pine how to actually do proper signal box wiring. So if you come and see me, you'll find it's all done in the correct cabling and done as such. So anyway, that's my very quick demonstration. So I hope that was useful, and I'll now hand over to the openSignalbox.
Well, yes. Well, can I pick up on a little bit of that? Something that I've seen an application for knowing, rather than just normal and reverse, the full position. Yeah. If you point the camera over here, we've got a gate wheel, and if you look down, there's a crank, and as the gate moves, the crank is going to move about 30 degrees. Now we've got a video of the gates opening, and what I wondered is if we can use, say, perhaps 60 different positions of the angle of that crank, and choose from one of 60 different positions in the video, so that as you wind the gate wheel, the video stays in tune with the speed that you're running. And I think, Laurence, you were saying that there's a control that you can, if you've got a video, you can control and say, I want to play such and such frame from within Python. So it should be fairly straightforward for me to read the proximity sensor and get the position and say, okay, we want frame number 17, and tell Python to display frame number 17, so that the gate wheel will move at the same speed as you wind the handle.
Yeah, I guess for anyone watching who's, camera too, for anyone watching who wasn't part of that conversation earlier, there's a library called Pygame, anyone who wants to do Python programming, which has a very powerful video playback function, and I've used it at Didcot Railway Centre and the Signalling Museum for playing back a video of the IECC operation, the computer-based signalling, and we have an LED colour light signal next to it, and there are certain frame numbers which we know is exactly when the aspect changes in the video, and then that pushes out through Python a message down to an Arduino to the electronics interface board, which then changes the aspect in the physical signal on the wall. So it's always very tightly coordinated because it's exactly when it changes in the video. But likewise, you could easily do this because you have access to video frame numbers. You can play frames at different rates, etc., etc. So there should be a way of doing that. So.
We can probably make a device to do that.
Yeah.
These easily, I'd say.
Just imagine spinning it and seeing the video go back.
Oh yeah. Well, we can certainly do that, but it'd be very quick if it's on here.
But we could also have a video of a semaphore arm going up.
I was just thinking the same thing.
As you pull the lever, the semaphore goes up at the right speed.
Yeah, and that could be useful in general for museums because it's not everyone can put up a semaphore signal.
Yeah,
that would be incredibly useful for Armathwaite.
Because you haven't got a semaphore signal.
Because we don't, exactly. And obviously we don't have mains power, but I'm looking into getting solar panels. But having that kind of a video screen simulation and having that timing right so that when visitors come, as we pull a lever, they can see on a screen it going up. That's something I can sell to John.
Yeah, but the other thing, thinking about Armathwaite and no power, is that I'm sure there are computer monitors that take a 12-volt input, so you don't need to faff around going from 12 to mains and back again. You can put a 12-volt monitor and power it from your laptop. So your laptop you charge at home, bring it with you, that runs and picks up the radio signal from the lever sensors and power and puts the video on a 12-volt monitor that's powered from a car battery that's trickle charged from a solar panel.
I'm fairly certain I've got a 12-volt monitor at home. My fiance used to build computers and he used to use Raspberry Pis. I've still got a Raspberry Pi somewhere that he built with a small 12-volt monitor, so that's possibly quite doable at Armathwaite.
You normally get them in like reversing kits for cars, the ones that aren't built into the mirror, and they'll come with a suction cup like this. And
I think I've got one of them as well.
But
power banks are quite inexpensive now, aren't they? Sort of camping style power banks, and you can have fixed solar panels.
They're quite big, aren't they? Chunky.
I have one of them as well.
As in they've got a lot of chargers, so you could run a whole day off.
You can run quite a lot of things.
Yeah, but the thing is, because Armathwaite, if you're only open typically one day a week, you've got 7 days of sunshine to trickle charge a car battery, which will
7 days of sunshine.
7 days of rain.
It's a good story until you said 7 days of sunshine at Armathwaite.
Okay, 7 days of daylight.
Another way of demonstrating semaphores off it, if you don't want to use a screen, I'm sure you could get a Garden Railway size
those
signals as well.
If
you wanted a...
I've got an all-gauge battery operated one that a friend is building for me, so I could put that somewhere in
what I was thinking of doing at Reedham was actually showing number 10. You can get you can buy these O-gauge motored signals.
Yeah, I've got one.
And I was going, again, it's only running on an ESP, so I was just going to program it such that it followed these signals. So I've actually got a couple at home. I was going to do that because my final plan is to actually build a mock-up of the single line with both ends, so that people can send trains to each other interactively and have a little train running between the two. That's my plan for Hive, which is the whole interactive visitor experience, which is what we're planning to develop there eventually.
There's a guy called John Fitness I've seen on Facebook. He does incredibly realistic replica signals, and they're also motor driven. He'd do to order.
So there's also the Quint signals,
well,
and he does miniature railway size. So there's a picture from David there. And it's lightweight because it's 3D printed, I think, and I think it's.
These little signals, they just have a servo in.
Servos from
this.
I mean, even if you didn't want to do electric, you could still run a wire from the lever and a reduction.
That is one of the
you can get the servos to mimic the bounce as well.
Yeah.
So it looks really good.
One of the main issues with Armathwaite is we don't have any road access at all. Everything is on foot up a very steep hill. So actually getting a proper semaphore signal put in there, it's not happening. So we need a team of ox to drive up the hill.
Can't you send the train up there?
Sorry?
Can't you send the train up there?
Drop them off an engineer's train.
I have asked Network Rail, could you drop stuff off for us? And
Not intentionally.
But a guy that works for the P-Way has said if they're ever doing work down in that section, if we need something dropped off and he's got a crane,
Yeah.
he would. But
Or if they bring a trolley down the track, maybe talk nicely to
Yeah.
them. When I was on the P-Way volunteering, I mean, I know anybody who's nice to us with cups of tea would return the
oh
favour.
no, we do a good line and tea and
Oh,
biscuits.
there you go then. One thing I'm interested in, I know this is a really good solution, but did you look at reeds and magnets? Reeds versus magnets?
I thought about reeds and magnets, I thought about the
Yeah.
metal detectors,
Yeah.
but ultimately when I found that this would do what I wanted, it was just sort of a Rolls-Royce solution.
Yeah.
And that is
Yeah.
quite expensive, I suppose, because those
It
are
lends
probably
itself to all the other
£15 a pop.
solutions. Is that
Yeah.
all?
Well, £15 plus the
That's not bad at all. Really.
attached to a little 12-watt power supply, so it's about probably comes out about £20 each. But the point is, once you've got 32 of them, that's still a lot of money.
Yes.
You know.
But there are simple
Yeah, but
solutions.
we've
living
only
lots of
got
reed
16.
switches.
Yeah, we've only got
Place
16.
there.
A lot of people
So
use
it's cheaper.
But you
the
might find for a
industrial
simulator you
proximity
don't
switches,
actually need
Yes.
to detect every
which
lever.
I think
Because I
makes
don't
it
detect
Then
every
you only get one
set
position,
point.
or
Yeah.
you've got to
because
put
by the
lenses
fact
in.
you've got
Yeah.
that signal off, the interlocking has allowed that route. So you don't have to actually detect every lever to make a simulator run.
See, we wouldn't need every lever because all of the points at Armathwaite are gone. So you
Yeah,
would,
yeah, so-
when it closed in '83,
They took them.
there was only 6 levers in operation.
Okay. So you only need to detect
So
those.
we'd only need
yeah.
6.
Yeah. So that's how I've gone from 60 to 32.
Yeah.
There are some spares at Reedham, but there's quite a few. There's another 5 points I'm not detecting. Because to get that signal off, that point has to be set correct because you've got the detection in the interlocking.
Okay, so yes, if you've got points with a signal at both ends, then the signal controls the movement of the train, so you
Yeah.
don't need to do that. At Lowdham, and in fact on most Midland boxes, the Midland were rather more frugal with signals, and so you've got a ground signal to let you out from the yard onto the main line, but you don't need any formal signal to let you from the main line into the yard. So if we're turning the clock back to the 1950s when the yard's open, then we would need to detect the points and then have some way of indicating to the computer that the signalman has given a hand signal to the driver
Okay.
to go over those points. So what we would probably want is a couple of buttons to say hand signal forwards and hand signal go to come towards, hand signal go away.
See, I've implemented my buttons on here,
Yes.
but you could have physical buttons.
But
Physical
they're
button.
effectively signals, aren't they, really? I guess.
Yes.
Yeah,
so-
Signal
so-
detection.
Yeah.
Yeah,
Yeah.
it's hand signal detection.
Yes.
Maybe it's hand signal detection.
I guess in a box you could mount a tasteful switch by the window
Yes.
to signify the signal going over to the window.
Yes.
Holding a flag.
So
Yeah, well, what we've done in the past is pretend to wave out the window because in compliance with rules and regulations, it's going to be displayed outside the box, so you can sneakily press a button while you're actually doing that.
yeah, I mean we could have 4 little buttons at each end of the box for hand signal come towards, hand signal go away, wave green flag, wave red flag.
Yeah.
So if you want a train to come and stop to the box for the instructions, as you clear the home signal, as the train comes quite or nearly to a stand, rule 39A, you then press the red flag button and the train will then come and stop at the box rather than proceeding through.
I mean, sorry, you were going to say?
Kevin suggested something very, very similar to that for Armathwaite because obviously the way we do demonstrations at the moment is not accurate. But he suggested putting buttons just on the back of the shelf.
Yeah.
So that they're hidden and it's discreet. So
Yes.
one person is running the demonstration of this is what the signalman does, and then somebody is cheekily stood here pressing buttons at the back of the shelf.
Yeah.
I mean, another thing that is technically feasible, but more effort, if people cared for it, is that you could make flags that tell the system that they're being waved.
Oh yeah,
Yeah,
You can have a
3D
3D print,
sensors on the flag.
you can have like a 3D printed butt of the flag that has an ESP
And it's
and a
tells us
USB
it's been
charger,
waved.
and it just, whenever it detects it shaking sufficiently, then it just sends the same Boolean on signal that the button would do if you push it. So it's all doable. The question is it's more of the maintenance aspects, because I think for people like myself and Maurice, it's not so difficult to make that. It's just we have to think about spares and maintenance and that sort of stuff.
What you do when it goes wrong.
Yeah.
Well, it's beyond my level of technical expertise, but once it's set up, if somebody showed me, if that goes wrong, you need to do that, I would be able to do it.
Sure. And for small stuff like that, it'd be easy to get 5 of them.
Yeah.
So that over a few, 10 years, you've got spares to switch over.
Yeah.
But still, so all of that sort of stuff's technically possible.
And I suppose another thing that's a few years away but could be possible is to have a video camera in the box and use AI to detect that the signalman is waving a flag or giving a signal or whatever, and so that the computer can see that the signalman has given this signal, so the trains will respond accordingly.
Yeah, I mean, if you could put a flag outside and you mask the area out the window, it then becomes fairly easy to do. But the only downside with computer vision systems like that is that you have to make sure the light sensitivity works in the range you need. Because you may find that most days it works, but on a summer's or an autumn's day or whenever, when the sun strikes a particular angle,
it all falls to pieces.
You can't detect anything because it's blinded, and so it can become unreliable.
Yeah,
so
sure. But I mean, the thing about a forum like this is that we can bat around ideas. Not that we're going to implement all of them next week.
But in that case, you can have a backup button.
Yes.
So if it does fail over, you've still got the button you push on the back of the.
Yes.
Same with detecting the flags being waved. If they packed up and there was a problem, you just go and push the hidden button instead.
Or have a screen where you've got all the buttons and you can press whatever button you want.
Maximum degraded mode working.
Are they touch interactive screens?
That is, for £35. Wave share, completely touch interactive.
It's a giant iPhone, really.
Oh wow!
You see?
Without the phone.
And it's just got an ESP in it, which has got 2 processors running about 240 megahertz. So I'm only using 1 core.
Does it talk TCP/IP?
It talks, it will do. It talks Bluetooth or Wi-Fi or the special protocol I'm using, which is ESP now, which only this type of chip understands, which is by default a 1 megabit per second protocol. So 1 megabit per second is enough for sending messages between items in a signal box. Even with my packets at 20 bytes.
Yes.
So So in reality, you could use these. The only thing I would say is you've got to be fairly competent in using what's called LVGL and Arduino to program this. So I would say
it's a good discrete handheld control for managing the box.
Yeah, but you see, ultimately it might be sensible to build a module for openSignalbox. We'll have to see. But you've still got to design your screen layout, which does require dragging things around. So that would be quite a lot of work, I suspect, to do an openSignalbox module for that.
Well, it's on the list.
Yeah.
These
are just standard widgets with standard sizes. I'm even using Owen Stratford's font, so I've converted Owen Stratford's font into LVGL. So all of this font is Owen's font. So to make it completely consistent was my plan. And even in the status screen, it's using that font.
So it's not LNER Gill Sans.
No, it's not. Well, it's as near as Owen can get to what would have been used. I think we were modelling about the 60s. So it's his Signalbox diagram font that he's taken from various other fonts and sort of rounded it exactly how he thinks it should be.
Okay, so another thing about the...
Sad.
Okay, so thinking a bit more about train control and the simulation of the passing of a train through a simulator, and I'm guessing you're probably going to talk about this in a bit more detail. But what we've seen at the very basic level, time interval track circuit, time interval track circuit, time interval track circuit. Then the next thing is, as you say, a database that says I've got a train of this length, and after time interval this set of track circuits will be occupied. Then after a little bit longer, that set of track circuits will be occupied, and so that can be handcrafted.
How I've done it is I've got 3 timers for each track circuit. I've got a pre-wait, so train is approaching that track circuit, pre-wait time. I've got the time the train is in that track circuit, which is the track circuit occupancy time, and I've got a post-wait, so it stays occupied for the length of time in the post wait. So all those can be could eventually be programmed from a database.
Right.
So basically, if the train's longer, you can increase the post wait,
Right.
so that
Okay.
it goes for however long it is for the length of
So
that
there's the
train.
overlap between.
Yeah,
Yeah,
because that's
between the
effectively
track
an
segments.
overlap between the
Yeah.
track circuits.
Yeah.
So you know that the train's about to enter the track circuit, which is a warning, which you might use. Then it's in the track circuit, and then there's a post wait while it delays while the end of the train.
But
passes
presumably,
through.
if you have a database, you can.
But every train can be different.
Yeah, but you can have a standard set of things for
Yeah.
trains, but you can also have, long train but asthmatic locomotive.
Yeah, oh yeah. That would be my plan. You'd be able to program every type of train, slow freight, fast passenger, train stopping at platform. You
Yeah.
could program it all, and then each train knows its description, and train 5 is at this point
Yeah.
in the diagram, and it would update appropriately. That's all in my software is ready to do it, but it's just time, isn't it,
Yeah.
to write
So,
it.
I mean, there's quite a lot of work in preparing that database, a lot
Yeah.
of calculation and stuff. I suppose then the next stage of automation is to say, okay, well, if we have a database that has the lengths of the track circuits
Yeah.
and the acceleration and maximum speed of trains, so that then when a signal clears, the train's starting from scratch and it's going to accelerate up. And so with Newton's laws of motion, you can say, after so many seconds it will be doing such and such speed. If it's done that acceleration over that speed, it's that the engine has travelled this. So the engine is at that point in time. The train is 35 wagons long, so it's going to occupy those track circuits. And then each second you say, okay, how fast has the train accelerated? Where is the engine now? It's now 30 feet further on. It's now on the next track circuit, but the back hasn't changed. And then another second later, and so you recalculate the position of the train in real time. And if a signal goes back to danger in front of it, it can then start to decelerate. Whereas if you've got a database of times, then trains wouldn't respond to signals in the same way.
That's it. The signal is off. The train sees the signal off it goes.
And
If
that's
you
it.
put the
You can't-
signal back and it's already seen
the go. It's
It's going
Yeah.
in my setup.
That
But
should
as I
be-
say, my simulator, the initial writing of my simulator wasn't to simulate a whole timetable. It's punters come up into my signal box at Reedham, and we're just showing them the train going through.
Yeah.
So, but there's no reason why that can't. But at the moment, it's doing times.
Yes.
In the long run, it could probably be made to do either, but it's just
Yeah.
writing code, isn't it?
Yes.
So when you start thinking through this, which you've been doing just now, I've done it a couple of years ago when we were coming up with architectures for SB. You quickly find that you have to do some things a bit differently. So even your second and third state, which is where you're having lookup times for lengths of trains, you need to make sure that your track circuits have a list of all of the trains that they think are in them. Because the problem is, if you have a train that you think is crossing a shared track circuit or something like that,
Yes.
or you're going over complicated point work, and you can end up having something that leaves or a platform occupancy, and then that deletes the other train that's also supposed to be where it is. You can have things.
How I've done it is each track circuit can only have one train in it, okay, and that train enters or exits that track circuit purely by whether there's a means for it to exit. So either there's no signal and it's allowed to move into the next track circuit. I have to know whether the train's an up train or a down train, or there's a signal off. If there's a signal off in the up direction, it becomes an up train and off it goes.
Yeah.
If there's a signal off in the down direction, it becomes a down train and off it goes. So if it then hits the next track circuit and there's no signal, it knows it's going in the down direction.
Yeah.
But every track circuit can only contain one train, because that's sort of the tenet of signalling. If you run two trains accidentally into the same track circuit because you can overcome the locking, because there's no locking in this, because I'm assuming the signal box got locking, then one of them will win, probably the second one will win.
But what
Because-
about when you have a platform track
Platform
circuit,
working, I was just going to say.
and I split my train in two, and the
Yeah.
first half leaves?
Well, I'm not,
I don't have any
I'm
trains
not
anymore.
simulating.
No, absolutely,
I
yeah.
could
yeah.
simulate
But
that.
it's a good
but
point
at
you
the moment
made,
I'm
yeah,
not.
is
Yeah.
that it's very much to do with the specifics,
Yeah.
and that's the best way of doing it when
Yeah.
you're going to do one.
Yeah.
one
But I
instance.
can make trains. If I pull a signal off from a siding where there's no track circuit, it will make a train
Yeah.
as well.
That's
So-
But you have to have done the thinking to get to the end game, but it's got to be baby steps.
Yes.
Yeah.
Because these things are potentially
very
you can
complicated.
make it complicated,
Yeah.
and if what I think you're trying to do is replicate Monday morning with late running goods train, that confuses us all when we run the simulation.
Yes.
You know, that's
I suppose the thing is that 99% of the time when the simulator runs, it's going to be for members of the public, and you just want to see one train come through.
Like I've
and
shown
that's-
you one
yeah,
train.
Yeah,
isn't
and
it?
that's what 99% of the people see. But the one day or weekend a year where we have a signalling gala and we actually want to see
Well, you
what
want
happens.
to
when-
really,
yes.
well,
and-
it's at Exeter West,
Yes.
where they want to run the box with 2 signalmen and a booking boy,
Yes.
exactly as it would on a summer Saturday.
Yeah.
You want to be able to simulate that.
Yes.
Yeah. Yeah.
So just thinking about track circuit occupying and clearing and things, it sounds like you were describing an algorithm which says when the loco goes past the joint of a track circuit it occupies, and when the brake van comes off the track circuit it deoccupies, and you keep a list. I was thinking of saying, okay, for each second you say, okay, where is the train? It is occupying that one, that one, that one, and that one, so we will make sure that those are occupied. So you don't rely on any history. A second later, the train is there, so that is occupied, and all the rest aren't. So rather than saying this has now changed state and doing a state, you say let's do it on a snapshot basis.
You need to do it for every train.
Oh, right,
can't,
yes, yeah.
You can't overwrite the occupancy of the track circuit
No,
with the
no,
last
we
train's
say
process. So it needs
this
to keep a
second,
list.
yeah, this second we are doing a snapshot, and we've got a train here and a train here, so occupied, 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 clear, 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 occupied, 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 clear, clear, clear.
Yeah, and then to
And
decide.
then you update the hardware,
That's it.
and then you do that calculation every second.
So to decide if the track circuit's dropped or not,
yeah.
it then goes, have I got more than 0 trains in me?
Oh, right,
yes,
yeah.
then I drop it.
Yes, okay.
So,
yes.
so my simulator has a 1 second sim, so it checks every second.
Yeah.
So it could easily implement that,
Yeah.
but it isn't at the moment. It's the entry time,
Yeah.
occupied time, exit time at the moment.
Mhm.
But that wouldn't be difficult to implement. In
So
reality.
do you cover light engine movements, but set it back to ECS and stuff like that?
It'll every
Is that
movement you
possible?
can do with a lever, it'll do with a
Yeah.
simulator. So you can bring a train out of the yard with 25. You can send it through the shunting signals, wrong line, and everything. This will do.
Yeah, I was thinking from the point of view of your track circuit's
And it's-
occupancy
it's-
problem. So if you've got
it's
platform
because-
line occupied,
Yeah.
Yeah.
No, there's no interlocking, so you can put 2 trains in a track.
so
But the
so you
problem
can't-
is, as soon as the second train's in the track, it overwrites the data. for the
yeah,
first
that's what
train.
I'm thinking.
So, but basically, it only looks at track circuit. So that track circuit has got those signals exiting that way and those signals that way. If it sees an off signal, it'll go.
yeah,
That particular train.
Yeah.
The simulator doesn't understand what a train is yet.
yeah.
It's just a train, and it's looking for a signal that's off.
Yeah, so if you're simulating, say, steam engine era working, where you're getting an engine come off, the passenger train arrives, engine comes off, leaves the
Yeah,
platform.
it probably won't do that.
Yeah. So
But,
it's kind of a problem.
You know, it's what I've done so
Oh,
far.
absolutely, yeah, no,
you should be working quicker.
Yeah, absolutely, yeah.
No, I'm not picking fault. I'm just saying that that would be one of the interesting problems.
I hadn't thought of splitting trains, so there's no
Yeah.
concept of train splitting.
Didn't happen at Reedham Junction.
Didn't have to bring it, not by plan anyway.
So you may get, like, say, a double unit DMU pull in, and it may split off.
Oh
one
yeah,
unit
and it may well have.
second
There may
line.
one bit might have gone to
Yeah.
Yarmouth and one bit closer.
Yeah.
And I think trains, Stephen did say to me, trains did join at Reedham.
Yes. Yeah.
And then go off. So you would have to be able to simulate that.
Yeah.
But you know, I am where I am. There's
Yeah.
only so many hours.
Oh no!
No, it's,
I think, as I say, the thing about this is to look into the
Yeah,
distant
yeah,
future and think where would we like to get to.
But you see, ultimately, once that structure is effectively a database table,
Yes.
or 2 database tables,
Mm.
then you can just write it at any minute.
Yes.
You know,
So-
you can say, I'm now waiting for a new database update
Mhm.
for what's going to happen next.
Yeah.
And then it's not in here, which is where you want to be. You want the logic in the database, and this is just simply running a process
Mhm.
for what the
so
data it can
your
see.
model's more one of having a sort of a pseudo GPS map of absolute coordinates plus length, and then
Yeah,
mapping
I
that
suppose
onto
that
the
was-
track circuits. So
Yeah,
you're saying
that was
the
my
train,
concept. Yeah.
the head of the train moves to these GPS coordinates, for example. It's at this length, it's going this speed. Then we map that
But
on top
it's
of the
totally
track circuits.
achievable. Totally
Yes.
achievable.
So
Yeah.
Swindon Panel did
Yeah.
that sort of thing,
Mm.
and I refer to it as a 1D physics-based sim.
Yes.
So it's a one-dimensional track,
Yeah.
And then the idea is that you have joins at all the points. So although the layout's two-dimensional, for the train it's one-dimensional. You can only go along the line. And then you have links at different ends. You measure your distances in miles and chains or meters, whatever you want to do that. You have a London end and a country end, or however you decide to do that. And then you have a train length, and then from that you can start moving them around and doing all that.
So you need a SQL database to put all your trains.
I'd always envisioned we would have a SQL database ultimately, with the timetable and everything in it. That was my ultimate vision.
Ooh.
Yeah.
So multiple SQL databases.
So to clarify what you're saying about the 1D route, rather than if you've got a facing junction with a left-hand route and a right-hand route, then if you pull off the left-hand signal, you're taking the left-hand route, and so that's a 1D route from the from the left-hand splitting signal to the starter on the left-hand branch, and that is just a straight route that has distances and track circuits and times. If, however, you'd change the points the other way and you'd pulled off the right-hand signal, that route doesn't exist anymore, and you've got a 1D route going the right-hand route through the right-hand pair of points, the points to the right-hand, and that has a different distance to its starter because its starter is in a different position, but it's a 1D route. And if you've got a 1D route and a train, it's dead easy because you know the length of the train, you know its speed, so you know where it is, you know where the head is along this 1D route. So it's just plotting it along a line. You don't need to do 2D GPS and all this lot. It's 1D along a line. And so
then you've got to define every one of those different lines.
So basically every single route that you can set, you have a 1D route that says if this signal is clear and this pair of points is normal, and that pair of points is reversed, then we're going round there, and so that is a route that has its set of distances.
You're just going to end up going down a rabbit hole because you end up specifying number of wagons in the train, number of type of wagons in the train, whether they're fitted or unfitted, type of locomotive, typical.
But that's okay once you're in a database.
Yes,
because you have 1,000
your timetable can
records, can't you?
Yeah, your
but it's not okay. It's not okay on this.
You've still got to do the bloody homework.
But also you don't have to manually specify everyone. You can set up rules for I want an average train length of 25 car wagons. I want it to go up to 35, down to 4. And I want
a random
random number generator.
With an element of randomness as well.
Random trains within a certain set of parameters.
But I'm never going to use that at Reedham with pointers that wander in, have a look for 5 minutes.
But I can see David wanting to do something like that here because that's
But I think the other side is not. I guess I'll talk about openSignalbox in a minute.
50 wagon.
The idea is that if we start connecting these boxes together, that's when it's going to be enthusiasts playing with their signal boxes, and that's when they're going to want to have real trains going through.
It'll be worse than Dungeons and Dragons.
Probably.
You've
also got great gradients and slippery rails as well.
Well, I've been asked to do fog working for one of the people who wants fog working.
Oh right, but certainly Will Troth and to a certain extent Alistair Larter, because they are creating a signal box for their own pleasure. It's a private signal box rather than one open to the public. Their aim is to make it as realistic as possible, so that as someone operating the signal box, they can do it as realistically as they can.
They've got the time to build the database record.
Yes, exactly. Yes.
As long as you give an interface, they can type it all in.
Absolutely.
And then maybe we can then use those records when they develop it.
It's part of the virtuous circle.
Well, I mean, on Howard's block post software at Exeter West, there's a timetable editor, and you buy the simulation that is the levers, the interlocking, the track diagram, and the train simulation, and people can write their own timetable and populate the length of the wagons, the weight of the train, the tractive force of the engine type, and what the whistle sounds like, and everything else.
They had banking up the hill, didn't they?
And you can program all that into the timetable, and then people submit those timetables back to Howard, and he publishes them and sells them.
I mean, there's another example of randomness for openSignalbox. For Alistair, we're planning on having you can define traction groups. So you can say, okay, I've got a service which is the summer Saturday passenger train for this. it can be hauled by a 31, a pair of 20s, a 47. I can even give pool allocations if I want, but then I say 80% of the time it's going to be a 47.
Yeah.
So 10% of the time it's going to be this. 2% of the time it's going to be this slow running emergency loco that we don't really want to have on it. And then every time it comes in, it picks that. And we have the sound effects for the different classes. And that's something which makes it fun for the operator because they don't know what's going to come until it comes down the line, which is true. You know,
and
so
worse than that, there's nobody that you can contact at the operation.
And the other thing, of course, is although the simulator is driven from the timetable, you can have and introduce random lateness.
yes, absolutely.
So trains will randomly come a little bit late or a lot later.
And you can always program, against more advanced timetabling for joining boxes together, delays can propagate.
Yes.
So you can say this service is formed by the incoming X. So if you've got a short end of a line, then if you send it down, you don't want it to appear 2 minutes after it went on the front of a different train. So that can go into, but it's.
Okay.
So we've already got a timetable.
Yeah.
In a usable form, which we could stick in a database.
Well, yes. Okay. So you've given me the spreadsheet that openSignalbox will use. So yes, one of our next jobs is to take our Excel file and just cut and paste and put it into the format and the right columns and everything, so that it's ready to go in there. So I think now over to you. Would you like to tell us where openSignalbox? Shall I hold?
There was one more comment. Sorry.
Talking about the element of randomness, there is a human element of randomness in all of this endeavour. For instance, I'm thinking about a friend who was taking her children to Penzance on Tuesday, and they ended up stuck outside of Euston for nearly 7 hours because somebody had
Top themselves.
it was a fatality, and you could see Avanti West Coast just backed up and backed up and backed up and backed up. Would it be possible to simulate for a certain section?
7 hours of no trains. Yes.
That's the default.
If you want a
setting.
quiet afternoon with a book in the signal.
There's a weird thing about Euston. They won't just rack them and stack them and bring them right up to Euston. They'll leave them at different stations along the line.
Absolutely, yeah. When I was
and they wait for a platform, and then that one goes, and then they wait for a platform, and that one goes.
yeah.
But
there was something
7 hours of no trains.
I used to be with the Swindon panel, and what was one of the things we would do when we were having a members session, not really when the public was in, but we would simulate a real issue with the track, or there'd be a delay at the fringe going off, and that's where this regulating comes into play, and you're like, well, I'll try and park a passenger train in a platform if I can, so that they can change or use the loo or anything like that.
Yeah.
And and then you think about how you stack trains, and in a lot of places in the UK, when you're getting bigger patches like that, you might have bi-directional working, and you can try and piggyback more important trains around them, and so that was a really interesting element to add to it. But I don't know if you don't tend to get it too much on smaller boxes like this. I think you can only have maybe a couple of trains.
But no, it was just how it was.
So it would have to be a bad circumstance to having more than one train stuck between here and
But one of the good points that raises, though, is when you're getting to a stage where you want to simulate a timetable, especially connected boxes, a lot of simulators won't allow you to be control and make control decisions. So they're the people who arrange the train services. So a lot of the time, if there's going to be delays and cancellations, it's control that make the cancellations, and they decide where to turn trains around, for crew allocations and other things.
Yeah.
And so it's very useful, and that's our intention with OSB, to do that, so that in the train planning module, which runs the timetabling and traction allocations, that control can come in and you can go, I want to insert this emergency timetable, I want to change this to this thing. Because a lot of the simpler signalling simulators, although brilliant, you can't do that. The only thing you can do is delete a train. And that's not necessarily what you want to do.
So for instance, at Lowdham, if you just point at the diagram, and I've got a pointy stick. So what we had is a coal train that was running late with an express following it. So we'd shunt it onto the wrong line, let the express go through, and then when the express cleared section, let the coal train carry on through. Is that the sort of thing that you were talking about?
Yeah, for sure.
So that's a decision where we're not sure whether it would be a telephone message from control to say put the coal train out the way for the express, or whether it would be a local decision that the signalman saw that the express is only 5 minutes behind the coal train, so it's well, it's my turn to shift it.
One of the things I guess I'll show you in a minute is one of the modules that we're using a lot at the moment, because openSignalbox isn't released. I guess I'll start talking about it in a second rather than just mentioning it. But a very important module at the moment is what I call macros, which I'll show you in a sec, which is like a flowchart you can build. So you can put the logic in a very user-friendly way. And what's nice with that, and the idea with this is the fact that you can start putting in all this custom logic. So there'll be macros, flows that you can use to simulate things that other people have written and standard ways of doing things. But then if you want to tweak things, if you want to put in this coal train that reverses and it needs a bit of extra, it'd be nice if something triggered or something went on, you can write that yourself. So then it gives you that flexibility that, for something like Howard's excellent simulations he does, you can't just say, I want to slightly tweak how the logic works, to do this. It's so I guess I'll talk a bit about openSignalbox for a few minutes. My background first, I don't work for the railways. I am an electronic engineer with swag, and I got into signalling preservation through Didcot Railway Centre and Swindon Panel Society. And then I met lots of really great people through that who were more than happy to teach me ins and outs and get involved even with some industry bits and bobs. So I've got experience with a few legacy signalling simulators. And one of the problems that I found with them, was that they're typically written by a single individual who's normally a retired programmer who does a fantastic job with what they're doing. But then 10 years later, you can't find the source code for it if you need to fix it anymore. It'll be written in a language perhaps that they knew very well but no one else did, etc., etc. Another thing that would be very nice is if we could connect signal boxes together, and that would be really fun, I think, and get a bit more use out of them. So I was approached by Alistair Larter, who's got his Sleep These project, to say, through a friend, to say, would you mind writing a simulator? And so I said to him, no, but please could I do it as a big open source project, which means I'm not going to get paid, but I want some more time to do it, because writing something that's user-friendly and generic enough that anyone can use it takes a lot longer, because you have to think about how you're going to write it a lot more, and it takes a lot longer to do that sort of thing. We decided we wanted it to be, I say we, there are 4 people in the core development team for it, of differing amounts of activity. But we decided that we wanted it to be not just installed in signal boxes, but also you can download it to run on your own computer. You can do everything virtually, so much like Blockpost or SimSig. If you don't have a signal box, it doesn't matter. It can be tied into model railways as well if you want to do that sort of thing. So it's very, very flexible. So the project itself, it's called the openSignalbox project. That's sort of this community-friendly, free effort to support this area. There's a piece of software that's being written called openSignalbox, confusingly I guess, and that's the simulator software that does all of this sort of thing. Also, as part of the project, we have hardware support too. So this ranges from, at the moment, a prescription, if you like, of recommended hardware interface boards. These are commercial off-the-shelf boards. So David here has a different version of basically the same thing. I think Maurice said you've at Reedham have got similar relay interface boards too. These can be connected in this case via Modbus, which is an industrial protocol that goes down 2 wires, which is very resilient to running next to relays and other things. But can also go over Wi-Fi and Ethernet. The way that Alistair's using it at the moment and the way I'm recommending it is he's got multiple of these boxes, and then they go into one of these, again off-the-shelf interface boards. So this will take the Modbus, the 2 wires that control everything. These are chainable, and then it goes into Ethernet. So this then goes into the computer that runs the simulator. These are about £10. This board, which is 16 inputs and 16 outputs, is about £45–50. You can get ones like this, which have got pluggable relays. So this one's really nice because if you do weld the contact for whatever reason, you can just swap the relay over. So that's that. So the update rate I was testing these with was about 10 times a second. So that's sending entire updates of maybe 100 outputs and inputs 10 times a second. Now for a mechanical box, detecting levers on and off and indicators, that's perfectly fast enough. However, for ringing bells, for older bells, which are rung more slowly, 10 times a second isn't so bad. But if you have a modern BR Penguin bell, which you can ring very fast, but modern signallers will run them even quicker than that and be very, very, very fast, then the 10 times a second wasn't really cutting it. So to do it properly, our first piece of hardware that we built, or I built, sorry, is this box here. This is very similar to Maurice's boxes. In fact, inside it has, I'm not going to open it actually, but it has the same chips really that Maurice is using. This has Wi-Fi and Modbus connections to tie into the physical Modbus system. And you can wire 4 BAL lines into this. This is the BAL interface board. It runs 1,000 times a second, so I challenge any current Bobby to be valving faster than that. And,
if you can, the bell won't ring at the other end fast enough.
You get a free mug.
Challenge accepted.
And so what happens is once it's listened to you ringing, it works out what it thinks the pauses and the dots and dials are, the spaces and the pauses, sorry, are. And then it interprets it as a code. It makes that available to the software. What it also does is it records all the actual timings, because what you can also do is connect multiple of these together. So you can have a mantelpiece here and one in the south or in Germany or wherever, and it will ring back faithfully the same taps that you did, so you can tell someone's personality.
How does it work?
Sorry?
How does it work?
How does it work? So inside it's got a microcontroller that's listening to the 4 inputs. Whenever you tap, there's what's called a state machine, which is a way that you can progress through different states. So a state might be idle, nothing's happening, and then you hit the first tap and it goes, well, I've got a first tap.
Yeah.
And then it measures all of the timings. As you're going through putting a code in, it works out the average length, and it actually groups them into shorts and longs. Yeah. So it has a dynamic threshold, which is quite nice because it means someone can jump straight on and do long, slow taps, and it still works. Yeah. A really fun thing with this is an idea that David provided, which was to be able to suggest a hint. So in some boxes you may have it that when you've been sent to one, you may reply to one depending on your working practice, but then you might want to immediately offer the next train to get in there. Yeah. So if it's a single line or something. So this needs to understand 2131, which is actually 241. If you're going to ring it really quickly, so
middle and main line. I mean, I think it is common for just one and unpeg and then rattle the next train straight off.
Yeah. That's it. So what you can do is you can tell this, I'm expecting the next to be 1 or 2 or something, and then as soon as it gets that, it will send it straight through and start listening for the next one.
That's excellent.
You don't have to wait and then send it through.
So that means if you've got you've sent me 2-1, so I'm replying 2-1, and then I'm immediately saying 3-1 because I want to send you an ordinary passenger train. So I go 2-1, 3-1, and rather than it saying, oh, that's a 4-number bell code, it's saying I've gobbled up the 2-1, and then here's a 3-1 as an ordinary passenger train. So you don't have to go 2-1, pause, 3-1. You can go 2-1, 3-1. Straight off.
So you've got the makings of an entry in the logbook as well, haven't you? Because you've got the time.
Record
it at the end of it.
So there's on. So that's the BAL interface at the moment. There's a new one in the development because this is just a BAL interface at the moment. What I'm going to replace it with is a universal block shelf interface, and this will control It's bipolar, so it basically gives you relay contacts, but they're silent, they're solid state. So you can mount this in your block shelf, and there's no clicking or anything. And you can do block instruments with the positive and negative to get the needles round. Also, some regions have a common positive versus common negative on their valves, so that causes issues with connecting power supplies otherwise. So that's completely separated. The universal interface will have little adapter boards, so you can plug in an adapter for different types of instrument, which makes it very easy to configure and change what you want on it. So that's hopefully this autumn, winter, I'll get the prototypes for that. I've got a friend who's got, I think, every block instrument under the sun, including the Scottish region, and so he's agreed to test the new board on those. So that should put it through its paces, hopefully. So that's that. What else do I want to show? Mugs. If anyone wants a mug today, feel free to take one with you. Maurice has bagsied the green one, but the other one's
the red one.
Sorry?
Can I bag some red one?
Yeah, you've got the red one.
Is it? Do you want donations?
No, it's fine. No worries. These are the samples. So that's that. So I guess so that's that. Other hardware things quickly to mention are. Also, we've got the diagram driver coming, so this is to drive Signalbox diagrams. It's modular. I mean, imagine this, and the idea is that you can then click more boards on to add more and more outputs for running more and more lamps. It will connect into things like openSignalbox or any code that you want to write through Wi-Fi and other things. But importantly, for museums and other places, it will have a USB socket that you can put a thumb drive in. And you can, on your computer, just edit a text file and put in all the pauses and what lamp you want to turn on and turn off. And what we'll probably do on our website is have a nice friendly editor for it that will do the text file for you and just save it out, so that you aren't just in Notepad.
What's the load capacity on the outputs? I mean, if you're running original diagrams, say with 24 volt bulbs, or maybe even 12 volt bulbs, will it handle that?
I mean, it's being designed at the moment. The bigger question is
slave it into relays,
specing the power supplies to go in.
Yeah.
So I can do the traces and the switches to switch them all. It's just, do I put a bus bar through the back?
Yeah.
Or do I have separate power per module, which might be a better thing, because then it puts it on the person if they want to do that sort of thing. But, what we also want to do, so on our website we've also got lots of 3D designs for, I say lots, but a growing number of 3D designs. We've got the traffic blacks for labelling and for the repeaters, which are available to 3D print if you've got people with 3D printers. So I can do 2-colour 3D printing. And I've done all of those for Royal Trough at the moment.
Yeah, I saw them in these Knighton Crossing group.
Yeah. So there's those ones. You can also use the same files just to give to an engraver, or drill out with a CNC machine or something, or just print them. Again, these use the fonts from Owen. Maurice has uploaded via me some Signalbox nameplate letters 3D that people can print out as well. The idea with all these hardware things is that the design files will be online for free, which you or anyone you know can use to print. But we'll also list people who are happy to be suppliers with their price and contact details. So for people who don't have access to it, they can then there'll be a little market there for people to do that.
And what's the website called? Where can I go?
You can Google openSignalbox, all one word, and it's the top result. But it's opensignalbox.org. Okay. And then if I could just get to my bag there, because I think I've put it back in. Another example is something we're doing. No, I put it down here, didn't I? Here it is. Sorry. So these are replacement wedge lamp indicators, like the old Mazda ones, the GPO ones, for the diagram lamps. These use an LED rather than a bulb, so they should last forever. And it's 3D printed wedge, and then the LED pushes in. The first design I did didn't have a built-in resistor, and you put in 12 volt LEDs. They're quite special and hard to find, and you don't have any flexibility for choosing the colour temperature because they're hard to find. So I designed this to have a resistor in the middle, and this means that you can use any LED you want and that you like and solder it in. So I sell these on the website. I don't make much money on them because they are quite a bit of effort to solder up. But West Somerset has amazingly put in a big order for them now. They've trialled them for a year in their diagrams. I had a a photo with Bishop's Lydiard diagram, and I went, oh, it's impressive, you've got Bishop's Lydiard diagram copy in your study, and there was a wider photograph of the steam train behind it. Oh, okay. So they've tested them, and I'm going to solder them up this autumn for them, and they're going to switch over today. So I mean, there's really nothing to them; they're just a piece of plastic. But you know, with the LED and the resistor, it's replaces the bulbs. So it's stuff like this that we're putting up, and if anyone has any requests, then that's something we want to do. We want to get designs for these tyres, lambing
3D
houses.
printed, there's a lot of demand for them, ever so expensive.
So we want to do that, and also the tyres double lamp diagram indicators. And for both of those, what I like to do is do an original version, and then also a version which just takes an LED inside it. So you can easily put in an LED module. And the other thing I'm trying to do with all of these designs, because I also want to do repeaters and things like that, is to make the new version with a lamp, with an LED, or with whatever we use for moving needles and things, as small as possible, such that it's easy for people to scale the design. If they want to have a miniature railway with a 1/3 or a 1/2 size, the same gubbins is in the middle, but it's just the case gets scaled, so that should make things easier.
Have you looked at the vintage London Midland region fluted caps? I mean, the same as at St Albans.
I haven't visited that one yet.
Well, nobody knows who made them. Nobody can't identify them, but apparently I think they've got the last ones in the world or something.
Oh, right.
Yeah, incredibly hard to get hold of, and once there's a broken and worn out, you won't be able to get any more.
Someone can draw it up then.
Well, I could probably let you have an original.
Yeah. I'm happy to add more to the
to
site.
have a look at, and you
So for that sort of thing, there's a website at the moment. There's a Facebook page, which is where I'm giving regular blog updates while it's all in development. We're also going to have a Facebook group, because the community is going to be the most important part. I haven't opened that up yet because I want the software to be released first so that people can talk. But then the idea is that if anyone wants anything more, if they've got any suggestions, it goes on there, and then me or anyone else can then jump in and do that.
Yeah. Sorry, I was saying the guys are doing kind of vintage London Midland diagrams. They usually have to resort to using the flat top. Radio space type panel lights, they just don't look right.
So for Alistair Larto, I also did some lens caps for them. So different plastics. So you can 3D print in resin the translucent red.
So I thought if you got a pattern for the fluted top, you could just 3D print it maybe. The backs are actually quite hard to get hold of, because the backs, I think they were brass, plated brass or something like that, and the cap had got brass threads cast into it.
Oh, I see.
I'll contact you and let you.
I mean, there's ways of doing that too. You can buy brass bushings that you can push into things, and what you can also with 3D printing now is you can pause it halfway through, drop it into a hole, and then print over to capture.
I suppose as long as you see the cap, I suppose it doesn't really matter, because normally the bushings are not visible.
And another thing that's doable now with the larger resin printers, you can actually print spectacle glasses, certainly for the miniature lamps, like the crossing lamps, LT lamps and stuff like that.
Pretty
so
cool.
there's options there. So that's the hardware side. The software side is the other thing I need to talk about. So it's not...
David, sorry, we have to go at 4 o'clock.
Oh, right, okay. So shall we pause this? And
you just hit the top. Well, I'll just give you a quick whiz of the software, which I can actually I'll probably hold it up here now, because I need a huge projector in there, David.
Sorry?
Need a huge projector. Data projector.
He's thinking of putting 3 or 4 rounds to just outside the window.
Well, because a module, as I was saying earlier, future module for SB is 3D rendering. So it's not just for that. So the first thought was level crossing CCTV that you can turn on and off. But then also, you could look at putting screens around the outside of the box, like they do for flight simulators. And I think in 10 years' time we'll be looking at virtual reality goggles or augmented reality goggles that show all of that. But then everyone can look like a plonker in there. Sorry, everyone can look more of a plonker in there. You're going to put that distantly, but back with the goggles. Be quite an expensive thing to hit against the block shelf. Right, so I guess what I was going to show was, I think, yes, that's it, perfect. The camera doesn't focus amazingly well because it's a fisheye lens, so it's I'll happily dub in some screenshots. So this is openSignalbox at the moment. It's this is showing a macro at the moment, but the idea is it's a website which when it loads up, which does have a dark mode because everybody likes dark mode. It's actually quite useful in the signal box at night to have the dark mode, and I'm intending there to be more colour schemes and all that malarkey. This is loading up the current state for Sleaford East, which is in development with Alistair Larter. The main thing is down the left-hand side here we've got different operation screens and configuration screens. It's very modular. Anyone can write modules, and the openSignalbox project will provide popular modules. So at the moment we have a module for interfaces. This is synchronizing up with the sorts of interfaces that Maurice has, the relay board, which we showed before, the BAL interface, etc., etc. We then have this module I've got called macros, and this is using this sort of flowchart style library. It's something called Blockly from Google, which is based on Scratch, which was a kids programming language. But the nice thing is, and this is currently showing a running one, but if I go to see this is the macro library, and what I may have done in the meantime is stopped the server while I wasn't running, so let's just see. Yes, I just need to go and restart the software. No, just keep it running, I'll cut it up. Because this has been sat here for a long time, I think I stopped it. So let's let it load up again. Loads up quite quickly. What's going on? Aha! Now it's all going wrong for the first time. What's gone on here? Let's have a look. Should be okay on that Wi-Fi. Normal service will be resumed shortly. That should be running. Shouldn't be a problem. Oh, there we go, it's working now. I don't know why that happens. Okay. But we're still running on the wide camera as well anyway, so so yes, so I can look up a list of all the macros that he's got at the moment. So these are these flowchart style ones. So at the moment we have, for example, rules for running the omnibus telephone, which Alistair has connected up. This can ring the phone bell. We have signal checks, so for trains waiting at a signal for so long time without the signal pulling off, it will ring the bell every couple of minutes to simulate the driver calling. And then at the moment, because we don't have this 1D physics sim in yet, this fancy simulator, we're using these macros, these flowcharts, to implement the same logic that Maurice has in his simulations, where we have this time-based pick track circuit drop. So I can show one of these here. This is down local to up joint or down branch. So if we go in edit mode, so we have this start block, and then we can drag in from this palette on the left different things. So wait for 1 second, wait until something is true, so this might be reading an input. We have different things we can use, actions they're called. So we're going wait until this shared variable, and these are bits of data published around the whole software. So in this case it's an interface, so I can click in here and this will let me select all of the different variables I have that are published by the different interfaces, and we set these up when we set up the interfaces. So we can assign one of the inputs on one of these BALs, for example. Let's say it was the A track repeat relay, A track circuit repeat relay, or it could be a so Alistair controls some of his colour light signals through relays from the software. So it's a Sleaford West 41 signal HR relay. So there's all these things we can select in there. We can also filter by the usernames, because this list can be quite long. Any tags that these have, we might put certain tags on to label up these different interfaces. And then we can say, so in this case we're saying if the signal's wait until the signal clears, so this is the entrance signal for this particular movement. Then if the point repeat relay, so this is the reverse repeat relay, then we want it to pick the Sleaford South up joint line clear, otherwise pick the down branch line clear. So this is simulating the block as well. So at the moment, this is a very simple block simulation because the BAL module hadn't been done. It now is, the BAL interfaces. We'll be rewriting this shortly to actually offer trains and accept them. But in this case, it was just simulating the line clear being given. So Alistair was just ringing out on the BAL himself and then running this. Then we wait for 10 seconds to simulate the train moving. We pick the K track repeat relay, indicator relay, and then again we check if the point is reverse. We then start going down this route. So we change over the block instrument. We then say we're going to pick one, then wait, then drop another, then wait. So Maurice was saying he has different predefined delays for the train moving. In this case, we're just doing all of that manually.
Well, I've had to define it manually anyway.
Yes.
Ultimately, it's just hard coded, so you can't change it.
But what we've also got in here now, so we don't quite have it yet, is I was going to put in, so I've got local variables which allow you to store information in here, which we'll see in a second with the BAL system. But I'm also going to add in global variables which allow you to define certain numbers and constants and text across the whole system. And one thing you could start to do is to define these delays by a set of coefficients for different types of trains, so that you can then start to put some selectivity in the speed that it's traversing. So rather than having to make a whole new macro for a slow train going through a section, you can start looking up the speeds. So that's another option. The other thing that we could add is, rather than wait for a time, we could have a wait for a distance, travelling a certain distance, which it just turns into a time in the background. So there's ways of doing that. But we don't put too much effort into that at the moment because we then want to just move on to writing this 1D physics-based sim, which I think is a better use of time. You can also call macros from within macros. So in this case, we're running macro 9 signal check. So that's in case it's stuck at signal 9, that's going to trigger the phone ringing every 2 minutes. We can run macros in parallel, or we can have it sit there and wait until it finishes and then come back into the program. So all that's doable. And then I think that's pretty much everything for here. So then another interesting one to see at the moment is what we've just added, which is the Sleaford West Main Up block. And this is working the block section. So we're going to keep running this all the time. We have a repeat while true, so this will always repeat. And first it reads the BAL code from the BAL interface into a local variable called BAL code. Then we check that BAL code. So we say if it is equal to nothing, which happens every time it goes round if you haven't sent a new BAL code, then it does nothing. If it's a 1, then it repeats 1. And in fact, it waits 2 seconds to simulate the bobby coming up and having to ring, calling attention. Then if it's 2, then we check that the block state, which is a variable we set just to track what the block state's doing internally, if that's line clear, then we're going to set it to train online. We're going to drop the line clear relay, wait and pick the train online relay. And this is particular to Alistair's wiring that he has with those 2 control relays. Then we're going to send the BAL code back to the BAL line to ring it back on that same line. If it's 2-1, it's a very similar thing. It's just we're going to switch it back to normal, just drop train online. And then at the moment, this is coded so for all other, which would typically be offering a train like a 3-1 or a 4 or a 5, it will pick the line clear if it was on normal, and it will send the same code back because we know we have a variable for that, so we just have to apply. Now you can then add before that 5-3, 3-5, all sorts of stuff you want to do. You can copy this, and we will do that for the different fringes to do all the different ones. You may want to customize certain fringes for different things. So it gives you a huge amount of flexibility, and it's coded in a very easy to understand way. So Alistair confessed to me at the beginning he's not a computer person. He's now a whiz at making these flowcharts. He's very happy with them. He's been sat at them because he can run it on his computer in the study. You can have multiple tabs open. You can copy and paste between macros open in different tabs. So it's really nice. So even just with the interfaces and the macros, you can now have a signalling simulator. You can pick and drop relays. You can have the delays. The next next current module writing over the next week, or I've done a prototype already, is this train planning one, where we're actually have timetabling, traction allocations, things like that. So the way at the moment that will integrate is the timetable will trigger macros. So it will trigger the trains entering, and it will pass with it train service information. So that will then be accessible inside the macro, so that you can say if the head code starts with a 2, with a 1, or however you want to do it. You don't have to use head codes. So for example, for Knighton, which is an earlier steam era box, there'll be a different ID number for the trains that you refer to, the 7 o'clock Bristol or something like this, rather than through a head code. So even with that, that's sort of how powerful we are at the moment. The other nice thing to show is, so when you run a macro, and let's do that block one. In fact, let's do a travelling one. So you hit start macro with defaults at the moment. You then there's a list of running macros. If you click into it, or hit play first actually, and click in, you actually get a live display of where it is in the macro. So it will highlight the current step that it's on. At the moment it's waiting for an interface that's never going to pick to come up, so we'll never see that move. But if there are any local variables, you'll also see it. So if I go back and start the BAL one, which at the moment is the only one that uses local variables, we'll also see if we go into that, hit stop. Okay. So at the moment it's got nothing, so it's going around and it's doing a wait loop. But we have the local variables down here. So at the moment block state is normal. I could put line clear in there and hit send, and that's now updated the internal state to line clear. So this is quite useful for rescuing currently running sims and for debugging if something's gone a bit wrong. You don't have to just delete everything and start again. There's probably ways you can, and you can design this when you're doing that you can come in and save things by just manually tweaking. So the important thing is to make it very flexible, because a point that was made when I first met David, which was at a Swindon panel technical seminar, is David had the excellent question of, can we gang together to make common support for these signal boxes? And a point that was made, which was valid, is that there is so much differentiation in operating practices, in local rules, in the style, in the wiring and everything, that it's very, very difficult to do anything fully generic, which is the power of having something like this macro module, which means that people can take generic macros and do those tweaks and then share them with each other. So we'll should be able to share these on our wiki. They're very easy to modify and share between people. The other module which we're very excited about being developed at the moment is an electrical locking module. So this simulates not just relays but other items from electrical signal box diagrams. It's very efficient, it's bipolar support, so you can simulate instruments and block lines. It has relay, you can put in different styles of relays, you can time all of the contact movements, making and breaking different sets of contacts, you can put in full Q style relays and all sorts of more complicated items, shaft relays. We've been testing it with route relay interlocking as well. So the idea is that we want to implement full simulations of standard relay interlocking systems, SW67, E10K Western Region, geographical interlocking. We have a user who wants to simulate the, I'll get this wrong now, AGC, AEI, the system from Perth up in Scotland, so the Scottish geographical interlocking. And we've done some testing on those circuits and they simulate perfectly fast enough, and that gives you full debugging, stuff like that. For entering these circuits, something that's going to be quite nice is you will be able to upload pictures of the pages of the book wiring and then actually draw the circuits over the book wiring. And then you can save those pages with the images in as well. So you can have a fully simulated sets of the actual drawings for your signal box, be it originals or ones that you've made. And then of course you can save those out to PDF. So if you want to do all the drawing in that software, then that's fine, and it will save drawing PDFs out for you. But it will then live simulate, and again, much like the macros, it highlights the execution, so you can see where the voltages are while you're designing and while you're testing it. So it's very good for debugging. You can also fail the relays in different ways. You can false feed things, and you can break things and break contacts. So So there's a lot of flexibility there. So that's another exciting one. And between that and the macro interface, that should cover most of the ways you need to talk to things in a signal box. And then the next thing will be adding this simulator in. But on top of that, there's a list on the website, opensignalbox.org, of the modules that we want to make. We're open for people to suggest other modules and, of course, create their own. But we've got other stuff down the line, like telephony, which I think is something Maurice will end up getting involved with, but you already have some other people for the hardware side, so we want to have a universal telephone adapter, which will connect things like magneto, central battery, all sorts of different omnibus telephones into modern conventional network telephony interfaces, and that will allow you to then have your own exchange set up and connect numbers to different boxes. And and that brings me on to one of the really fun things with OSB is to connect different boxes together. So we're not quite at that stage yet, but the idea is that there'll be different modes you can fringe boxes together, either by having effectively an automatic signalman, which if you're going from say a 4-track to a 2-track, you can set basic rules up to prioritise different trains, or you just ignore the 2 of the tracks. So you come up with different modes for doing that. And then a timetabling system, which will then allow you to create timetables which work with the combination of locations that you want to do. Because that would be quite difficult to do ad hoc. So the idea is that the timetabling system, it knows what the lengths and the delays are, and it can try and come up with a timetable based on the services that you want in there. And then I guess, yes, the other fun thing to mention about the 1D physics-based sim, which will be our sort of full simulator that simulates stopping and braking, and as David was saying earlier, is again to enter data there. You want it so that you can draw the layout on the web page. So rather than having to type in this track section is this long and it does that. And then you can, on the background, have like the National Library of Scotland vintage maps, or Google Maps, or your own drawing of your layout from Templot or whatever model railway thing you want to do. And you can drag along, you can put in a scale bar which will calibrate the scale. And there's a really good Polish signalling sim called ISDR, which is actually used for training Polish signallers, and they have a brilliant way of displaying it. It's a 2D vector-based graphics, white background, black lines for all of the lines and the parts, and they actually live show the trains moving around on there. And that's really nice for debugging and seeing where everything is. So our plan is to have it that you can sketch that out, you can then start dragging block sections, signals, things like that on, and attach them to points on those lines that you've drawn for the track. So that also makes it very easy to place those sorts of things and say where your fringes are and stuff like that. So that's the plan there, and that should hopefully make it easier for different people to add that level of simulation. Because I think something that's in everyone's mind is the fact that it's great having all of this capacity to do things with the technology, but if it requires a huge amount of work to do the customization each time, so we need to make it simple. And again, that's another reason why OSB takes a long time to develop, because we've got to make it easy enough for people to be able to, we need to build a community so that everyone can support each other online, so that 10 people know how to do the macros, and on the Facebook group when it runs, then they can support other people and do that sort of thing. So that's an overview of OSB. Timeline wise, I think so. Alistair's got an open day, or private open day next week, which was supposed to be a release date for it. We're going to miss that. There will be I'd like to say I think there'll be a release for people like myself and Maurice and interested technical people, anyone who wants to get a copy of it unfinished but in an alpha state. And that will be before the end of the year for sure, probably looking at October sometime. An actual release that anyone can download and run will be sometime next year. And that will be a one-click installer where it installs the software, starts up, opens the web page, and you're running. So yes, please visit the website and stay tuned. And that's openSignalbox.
Have you had any interest from Network Rail?
I've had a lot of people telling me that I have interest from it. I have no interest in interacting there because I know what's involved with that, and I don't have any interest in that side. There's also sort of things I want to steer clear of that are involved in that side. So no, source now at the beginning. So if they want to go and do stuff, then they can. Any other company who wants to use openSignalbox to make a commercial product can do it, subject to the licensing, which is an LGPL license. So they would need to credit, and they're not allowed to then share the code closed again if it's not being credited.
Derive for profit.
That's it. And also because it's LGPL, that's because it's network hosted. So that means they can't also host services that are running openSignalbox on their servers somewhere and not credit openSignalbox. So it also has to, but the license details are online. But aside from that, I've got no issue with anything like that. The other thing, as I said before, money-wise, for people who want to sell the hardware, they can advertise that they're going to, provide stuff themselves. Myself and anyone else who wants to in future can offer services for support for openSignalbox. Personally, I just ask for people to cover my cost for travel and board. Certainly for museums, for private individuals, and obviously negotiate. But it's a hobby and an interest for me, so I'm not in any way here to make money out of it. So, but yes, there are a few companies, signalling providers, who said in future they'd like to use aspects of it internally just for development. And of course, that's up for them to do because it's all open source. So, and of course, if some of those people then can contribute, then this is brilliant.
Well, fingers crossed they'll feed something useful back in, same as with Linux.
Yeah.
Thank you
models we've got.
very much. That's very interesting.
Okay, so
Challenging.
So in terms of how the various things interact to each other, so the Blockly macros, is that being executed by Google provided code?
No, so it's just a library that they provided. So
Right.
Blockly is that's the front end, so the website. That gives you all of the interface for dragging and dropping.
Right.
And you define a palette of what you want them to be able to do. So the types of puzzle pieces, the fields you can type in, what you think, And then once it's finished and you hit save, the website sends a JSON representation, so a structured representation of that map, to the back end, which effectively is a server running on the computer.
Right.
And it then takes that, parses it all, understands what's going on when you're running the macro.
So the actual running of the macro is something that you've written. So a macro follower, a state machine that follows the macro, is something that you've written. But the macro editing function is Google.
Is an external library,
Okay, so then the next thing is, how do you join, and when in the macro it says pick and a relay, how does that become a Modbus command to relay 22 to energize?
That's a very good question. So when the interface module starts up, you've put in a configuration when you edited the interface. You've said I've got 16 channels here. You could have said I only have 4. And then for say relay 4, you would define a shared variable. This is something that's visible across the whole of openSignalbox.
Right.
And you say I want to call this ATPR. I can put in a description and things like that and tagged. And then when the interface module loads up, or when you hit save, it will create this shared variable, which is whenever it's updated over the network, any subscribers will get a message to say the value's changed. So this is a Boolean shared variable, an on-off shared variable. Now then when you go into the macro and you say I want to pick something, originally it's just an empty box, and you click in the empty box, and it does a request to the main openSignalbox module to say, what are all of the Boolean shared variables that I could pick from, please? And then it will then, with its cache and of interrogated modules, know what all of the different ones are available that it could subscribe to. And it sends that list back. That's the list that you can select from on the right. You then just pick, and it just puts the string in that box so that we know later that's what it wants to use. Then when you run the macro, when it goes through, it will see that as an input to the pick command. It gives it knows it's a shared variable, and then there's a messaging subsystem underneath which checks what the last update from. So there's a cache as well for all of the messages. So at the moment the macro system is polling based. The macros there's a system tick that gets sent to all the modules at a certain rate. And then the macro module, when it receives a tick, it will go through the whole list of macros and try and execute them all. And when each macro is executed, it'll actually run all the steps until it hits a wait or something that's blocking, and then it will skip to the next macro. The wait functions, they don't just sit there and time out. They use the fast clock, so which can run more than the normal clock, the simulating clock, to then project the time in the future that they then are then expired. So every time it goes through, if it's on a wait for 2 seconds, as soon as it hits wait for 2 seconds the first time, it says, well, what's 2 seconds from now? And it stores that. Then every time it goes through, it goes, am I past that time on my fast clock? And if I am, then it goes to the next action, goes through. And so this makes it all asynchronous so that it can do them all in parallel. In future, I want to support asynchronous running, so non-blocking. So the some macros only get fired off and updated when the variables change. So they'll know what the dependent variables are for each macro. It already knows that. I've already put the backing in for that. But it was much easier to get up and running with a polling system, because there'll be a lot of debugging to make the asynchronous work fully. So part of it's asynchronous, part of it's polling. Then once it knows. Sorry, you asked about picking. So it picks. It gets that value, it then sends the message through what's called 0MQ, which is the messaging backbone I use for openSignalbox. That message gets sent around the network, and then the subscribing modules hear that. And so the interface module has a subscription for that, and it also has a polling loop that goes round, and it says, oh, this is now updated, so then it triggers the Modbus command which sends it out.
Okay, so in fact, for my board here that's there, I would have a new module that says, okay, so to pick relay 4, I need to send an I4 command to port 5000 on IP address this. And so the module subscribes to messages, and if it sees a pick Burton Joyce block line clear, then it says, oh, I know Burton Joyce block line clear is my relay 4, so I'll send an I4 to that IP address. Yeah,
so what I would do for your one, and what I started to do on the train was, but you won't see anything here because I can't show you it, is on the interface list. So these are all the interfaces that Alistair has. So let's say it was, so a good one to show is Billingborough, because it's got 8 inputs and 8 outputs. So it's disabled and disconnected at the moment because it timed out trying to connect the adapter that doesn't exist.
Is this actually recording?
Yes. It is, yeah.
It says 29, that's frozen.
Oh, okay, well, that's not good. It's gone very jerky as well. Oh, it's kicked into some custom mode. I'm not sure.
Unfortunately, I think we've missed most of the things right. Since the.
Well, I've got the audio from that, and I can dub over the.
You can do screenshots and drop them in.
Yeah, well, I think it went into time lapse mode, so I'm not sure. Video. So that should. Is that back in? Yeah, there we go. So if you. There we go. So then down here for the live input mapping, this isn't in edit mode at the moment, this is in run mode, and so for example there's logic for forcing so this is the input, so we can force the input which will update the variable for testing, or if something's disabled or disconnected. You can also see the mapping to the shared variables. And then on this side, these are subscriptions for the outputs. So channel 1 is subscribed to macros/billout1, and I can also force. This won't update because at the moment there's no hardware connected, and that's trying to show you what the real thing's doing. But if we go up into edit, so this is the general details. What we would do for your Dingtium board is we'd have a new type of connection type, which would be whatever you want to call it, HTTP, DT1 or something like that. And then in the loop that does the sync back and forth between the interface driver and the board, that would just be done over HTTP. So if you didn't want to do all 16 at a time, then you could just do change detection in the driver, which I do for some stuff, and then only send the updates when you want to do that. It is useful to at least periodically send all of them, because if you've lost sync, then that's a problem. That's something that Swindon Planning used to have, where you'd have to go and toggle all the switches sometimes to get it to resync. So for input configuration here, this is where you define the shared variable that you want it to host for each input. And then on output configuration, this is where, again, you select the variable you'd like it to subscribe to. So when that variable changes, it will then push the change out through the board.
Okay. So what's listening? So my board is doing a put to a URL, and so I would then have my own bit of Python that is listening for that, and it sees the URL, it parsed it and that. So would the Python then say, hey, this variable has now changed state? Or
so what I tend to do is just synchronize a set of registers in the interface driver with the I/O board, and then the shared variable system will pull from that. So you'll just write bits for a loop. So there's 4 functions at the moment. There's connect, disconnect, read data, send data, and receive data. And so you just have to fill in for those 4 functions, and that defines a connection. So the connection from this board, this basic I/O interface, to the software. So the interface itself has all of the business logic for how to control that interface. So things like having forcing for these I/O things. For the BAL, it has code parsing logic in it, things like that. Well, not code parsing, but how to then send that across the rest of openSignalbox. For what a connection is a connection is a way of customizing the way that it synchronizes the data it represents that with to the actual hardware device. So you have the same relay board, it's just you connect to it through a different way, which means it's the same interface type, but you would have a new connection type. So it should be very skinny what we have to do to add that in. So and then I guess, as an example, what we're doing with the BAL at the moment.
I'm really interested.
Can't show it's running, but for example, on the BAL control, rather than having forcing, at the moment, this is early days for this, but you can type in, I want to send a code, and then if you hit enter, it would then send it through to the BAL code for testing, and anything being received will appear live here. So one thing I need to add to it is long presses and releases for doing token releases and things like that. So there'll be a force option as well, and there'll be a type of message which is for doing that. So yes, that's
let go.
Right.
It's gone back to reverse check position.
Okay, I'll pause that for a moment.
Okay.
Okay, so
this is nothing to do with railway. I'll just show you some of the things I've done.
So look at gates, over the gate, first gates.
right, okay, so for the video I'll show what I've got in terms of what I can control from the thing by just pressing the buttons on the interface. And then we can and then I think what I'll do for the video is run a train through so that each of the videos appears and we can just see what the videos do.
I'm going to have to go very shortly.
Yes, okay. Right. Okay, so okay, would someone like to do camera and
Maurice can do the cricket.
yeah.
Well, I'll just demonstrate one of the things you can do with those displays. Something I did for Fram College.
Turn the volume down.
So I was just showing that off. That just connects Bluetooth to the phone. Hence these, you see. But I thought I bought it, so I might as well show it.
What was surprising about that though is the two halves of it showing slightly different colour
Well,
temperatures.
I think I bought 2 and then one didn't work, so I just got another one. But if you make a real display, you buy
You buy them at the same
that
time.
match. Yeah. And the other thing is it's scalable. You can make it as big as you want because everything just.
You know, you can have a proper Trent Bridge size scoreboard,
Yeah.
can't you?
Yes, okay. Okay.
You can stop it in two ways. You can start it in two ways.
Okay, so
Right, should we go?
yeah. Okay, so we've got a Lincoln relay control program, and the relays here are wired up to various functions on the block shelf. So, for instance, the computer can
Summon trains.
yes, so the computer can peg up a line clear or a train online. So I know that well, when the computer's not actively controlling it, you still got the manual control. So the idea there is if a train has arrived at your home track circuit berth where you've pulled off the home signal, the computer can force it to train online as a relay would in real life. There is no reality for wanting to force a line clear, except for the fact that given that I've got the relays in place, it means that if you want to do a look no hands demonstration, particularly picking up real-time trains from the Network Rail database, then without doing anything, the blocks can all do what they would do both ends of it. But more usefully from the simulation point of view is being able to control line clear and train online on the non-peggers. I can also simulate a lamp failure, which is now appeared there, and if the lamp is then restored, you can do that. And for just controlling the signal box in line with the Network Rail live database, we can also ring a platform bell downstairs, and we can also ring the train approaching bell in the box, and we can also control the so that's how I've wired the block shelf up in anticipation of having control from openSignalbox. But I've always done it so that when all the relays are in the normal position, then there is another way of controlling it through a little button box that we have here. So this represents the block instrument and bell for each of the two directions. So the train approaching bell can run there. We can do the two block bells, and we can give line clear or train online there and at this end. So with all the relays off, then these switches are connected to the non-peggers, and the peggers are connected to the LEDs on the button box.
So those are changeover contacts on the relays?
Yes, yes. So it's either forcing it or passing it through to here. So it means that we can run a train fairly effectively. So without worrying about gates and signals, let's just do the block. So if you could offer me a 3-1 from Burton Lewis. And I can give you a line clear.
Done this before.
You can give me a train online. And I can pay attention. And you can give me a line clear. And the train can come through, so I can give you train entering section, and then I can give you train out of section there, and then you can give me train out of section. And so that's how we simulate it at the moment. So it's manual, but by teeing the openSignalbox bell interface board onto the two wires that come out of the bell units, and that then openSignalbox can do the remote signalman in both directions, and by picking various relays from the openSignalbox macros, it can then give a line clear at the far ends and respond accordingly. So that should be that's sort of ready to go.
Put you out of a job then.
Set on one time.
So so that's that side of preparing Lowdham for openSignalbox. The other thing I've got is a very simple Python program that listens for certain levers changing state. Can I plug that into the HDMI cord?
It's the authentic Midlands HDMI cable.
Yeah.
The Western only wish they had this.
Yeah. So we have a monitor up there. So when I then unlock the gates, there is then a video of the gates being wound, which I can do sort of in synchronization here. Only the virtual gates are a bit quicker than me. Having done that, I'm then in a position to pull off. So if I pull number 12, that has a little video on it, and that should. Pause for a moment. Let me just make sure that this is running. 14. Is it still thinking it's done? No, just when you want it to work, it doesn't. Okay, so now having 8 seconds after pulling the distance signal, we now get a train approaching, and the train comes through.
It's the trainee box, man.
Against regulations of course. He's not an inspector.
So this looks like a stopping passenger train. Now it's clear of the distance. I can put the distance back. I can put the home back. Unfortunately, the train doesn't actually quite stop, which is. And it's still under power, so it must have really good brakes.
It's efficient. Don't need it to stop.
London commuters are anything to go by. They wouldn't bother them.
Probably be all off the train by the time.
Getting on and getting off moving trains is not a problem.
As the train goes past the box, the track circuit has now become occupied. And we can see that the train's got a tail light. So we can now unlock the gates and wind the gates open. And when the track circuit's clear, let's start that. So what that demonstrates is lever sensors sending a very simple message to a Python program. So the Dingtian board is actually doing an HTTP put to a program that's listening for HTML requests, and when it sees a certain lever normal or lever reversed, it's playing a sound effect or a video. So it's incredibly simple, but actually quite effective for minimum effort, and it means that I've got something to show people while I'm waiting for openSignalbox. I think that's all, so I think we'll close the conference there unless anyone's got any questions.